In the previous video, we discussed about continuity of a function and also the algebra of continuity of functions or continuous functions, isn't it? Let's look at few examples in this particular video as to how do we prove that the function is continuous at a point and in a particular region. All right. So let's look at this example. Check whether the function f of x is equal to sine square x is continuous at x is equal to pi by 2. Okay, the question is check whether f of x is sine square x is continuous at x is equal to pi by 2 or not. So you have to check whether it is continuous or not. Now, for this one, first thing, what do we do? Now, for a function to be continuous, how do you do it? We take f of x as x tending to c. If that is equal to f of c, then we say that it is continuous, correct? Or if the function is defined at that particular point, then you can go ahead and say that the next step you can go about it and you can say that, yeah, it is going to be continuous, isn't it? So here, what we do now, limit, the condition is what? Limit as x tending to c, f of x is equal to f of c, isn't it? This is what we have. But in this case, my c value is nothing but pi by 2, correct? So what we do, we write f of pi by 2. This is nothing but sine square pi by 2. Sine square pi by 2 is 1, which is sine pi by 2 whole square. Sine pi by 2 is 1, isn't it? So f of pi by 2 is 1. Now what you do, limit as x tending to pi by 2 sine square x. So this is going to give me, if this value is 1, then we can say that it is continuous at x is equal to pi by 2, isn't it? Now, how do we solve this one? It's going to be very easy. So you can write this as limit as x tending to pi by 2 sine x whole square. You might as well just apply the value, isn't it? If you apply, then this is going to be sine pi by 2 whole square. Sine pi by 2 is 1, 1 square is 1. So what did we prove? So here we proved this particular condition, isn't it? Limit as x tending to c, f of x is equal to f of c. Since we know this condition is true, so what can we say or what can we conclude from this? You can say, therefore, f of x is continuous at x is equal to pi by 2. F of x is continuous at x is equal to pi by 2. Understood? Now, this is for a particular point. Okay. Now, in the next one, we'll look into next example where I'll show you. You just have to discuss the continuity of this particular problem, right? The function is this. So, basically the problem will be discuss the continuity of the particular function or check whether the function is continuous in the given region or not. Something like this. So, it's going to be like this. F of x is equal to, so two things I'll give you. So here it's going to be 1, x is greater than or equal to 0 and minus 1 if x is less than 0. Alright. Now here I'll ask you what is the function continuous in a particular region. So when you have this particular function, again what we'll do, we'll take two cases here. So one is going to be the less than part, one more is going to be the greater than part, greater than or equal to part. All right. So first thing what we have, we take the limit, but we take the left hand limit. In the sense, what we do is we take limit as x tending to, here it's less than 0, isn't it? So 0 minus f of x. So this value is nothing but negative 1. Correct? It is negative 1. So next what we have, the next thing will be, we'll take it equal to. That means limit as x tending to 0 f of x. This value is nothing but 1 because we have f of x. If x is equal to 0, the function value is 1. Now the last part, limit as x tending to 0 plus f of x. This value is also 1 because greater than 0 is also 1, correct? So now what do you see here? That left hand limit, right hand limit, and the value at that point, all three are not the same, correct? So that means it is not continuous at x is equal to 0. Understood? Now here when we talk about the range, or you can say the domain in which the value is going to be continuous or not, generally you're going to have functions like these, either less than 0, greater than 0, or whatever values you can have. Understood? So here we can say limit as extending to whatever that value f of x, you're going to get that value, isn't it? One you have greater than or equal to 0, one you have less than 0. That means we have the right hand limit, left hand limit, and the limit at that particular point. So in this question, if I'm asking you that define, is this particular function going to be continuous or not? So here I'm taking into consideration as point x is equal to 0. So here, is it continuous? It is not. All right, so what we can conclude and write here, since LHL is not equal to RHL, f of x is discontinuous at x is equal to 0. So f of x is discontinuous. Understood? So this is how we solve the problems. Now in the next video onwards, from the next video onwards, you're going to look into different types of problems. There are around 5 types of problems in continuity. We'll discuss all the 5 types of problems.